Let's look at the second type of chemical bonding called the covalent bonding. Let's look at the second type of chemical bonding called the covalent chemical bonding, or perhaps covalent bonding. Put on place. Here, there is no transfer of electron, but here there is no transfer of electron between the atom. Instead, there is a sharing of a pair of electrons between the two reacting atoms so that both can attain stability, in bracket octet slash duplet. Close the bracket, please. So when it comes to covalent bonding, we don't transfer electron here. Rather, we share electron. So basically, for the first one we did there, for our previous video, when we did electrovalent bonding, that one deals with what transfer of electron. And I gave you several examples that you should know. That when you see them in an exam, you should know that this one is a what? It's an electrovalent bonding, like MgCl2, KCl. I give you KCl, right, and others, etc. NaCl. I gave you those one last class, right? You should know that those ones are what the electrovalent bonding. Let's look at covalent bonding there. For this one day, we don't transfer. Rather, we what there we share electron for them to be what? For the two reacting atoms to be stable. So note that the key word there is share. When it comes to covalent, it's just share. The key word for the last one we did last class, which is equivalent, is what the transfer. All right, at this point now, note that when it comes to covalent bonding, there are two types there. Number one, there are two types of covalent bonding. Number one, what we call the ordinary covalent bonding, and number two, we have the coordinate covalent bonding. So these are like the two types of covalent bonding that we have. We have the ordinary covalent bonding and we have the coordinate covalent bonding. Let's look at this type of bonding one after the other. Let's start the first one there, called the ordinary covalent. Let's look at the ordinary covalent bonding. Put down, please. Put down. For ordinary covalent bonding, each reacting atom contributes one electron each to become shared by the atom involved. Full stop. The pair of electrons shared is called shared pair. I mean shared pair. Shared pair. I have this one here. So I'm saying that the pair of electrons shared is called shared pair. Full stop. Let's look at example of ordinary covalent bonding. Is in form of, let me give you some example so that you can identify when it comes to covalent bonding, the ordinary, how do you identify them in exam. I gave you last class for covalent bonding. I gave you like 5 examples there. For this one now, for ordinary covalent bonding, let me give you the kinds of examples you expect for this one here. So let's look at example of ordinary covalent bonding. Let's see number one there. Example of ordinary covalent number one, we have the hydrogen molecule. Hydrogen molecule, that's H2. Number two, we have chlorine molecule, that's Cl2, right? Number three, we have a water molecule, water molecule, that's H2O, we have methane molecule. Number 4, methane molecule, that's CH4. All right, all these are simply example of ordinary covalent bonding, please. So in essence, let me show you something. Let me give an expo, an hint. When it comes to electrovalent bonding, there I give several examples, right? Last class I gave you NaCl, I gave you magnesium chloride, I gave you aluminum 2 oxygen 3, right? I gave you that last class. I also gave you magnesium and chlorine together. I gave you them. Those one they are for electrovalent bonding. For covalent, there are two types. So listen, there are two types. We have the ordinary and the coordinate. For ordinary, how do you know them? For ordinary, here's the thing. Every diatomic molecule, or perhaps every diatomic molecule, the bonding is called equivalent bonding. That is, when it comes to di 2, observe that this is H2, this is diatomic, Cl2 diatomic, H2 diatomic. So for every diatomic molecule, that refers to as what? Ordinary covalent bonding. So when you have a compound that has the atomic concept, it should be a what? A ordinary covalent bonding. Please let me show you number 1 to prove that this is a what? A covalent bonding, that is a ordinary covalent bonding. We say when it comes to covalent bonding, the keyword there is what? Share, not transfer. Please, the keyword there is share, not transfer. Let's pick out number 1 to explain this and a half. For hydrogen molecule, example, I have hydrogen molecule, that's what the H2 hydrogen molecule. Basically, it means that I'm adding hydrogen with what? Hydrogen together, right? Of course, adding atom number 1, Abi, my shell becomes just 1 hydrogen, just 1, plus hydrogen here becomes just 1 too. Basically, I can't transfer electron here. Why? If I transfer this one here, for it to be stable, observe this hydrogen now will not die off. It will not exist. It will be eliminated, and we don't want to eliminate it. We said when it comes to chemical bonding, we are trying to make the two of them to be stable, not one eliminating the other. If I transfer this one will be dead. That's the concept. So this one now, you can see that clearly that I can't transfer here. I can only what? Share. So these two will not combine to share in this form. This one here becomes this. I have this one. This one too will come and join this way. So I have this. So these two have now shared their electron for the two of them to be stable. This becomes your concept behind ordinary covalent bonding. Look at the second one there, called the coordinate bonding, and we're off. Number 2, let's look at coordinate covalent bonding. Let's look at coordinate covalent bonding. Put on, please. Coordinate covalent bonding, also called dative covalent bonding. Dative covalent bonding, very important. Either I call it dative covalent bonding or I call it coordinate covalent bonding, still the same thing. Put on, please. Also called dative covalent bonding, like the ordinary covalent bonding, there is a sharing of electron But unlike the ordinary covalent bonding, the electron to be shared is donated one by only one of the atom involved in the bonding. The electron shared is called the lone pair. The lone pair. So the electron shared here is called what? The lone pair. That is, when it comes to coordinate covalent bonding, there I can also call it dative bonding, right? So in this case here too, we try to also transfer electron, but basically they said basically here, the electron to be shared is donated by only one of the atom involved in the bonding, right? So when it comes to covalent bonding, the keyword there is lone pair, right? This one here is referred to as shared pair, right? So the difference there is shared paired. This one is what? Lone pair. Just one electron do the sharing, right? So this is lone shared paired and lone paired. They can ask you in jam that they can ask you that H2, is it a shared pair or a lone pair? You should know that is what? A shared pair, right? So try to know all this example I gave you. It helps you in exam basically, right? So this is like the concept behind covalent bonding. Let me give you example of compound that exhibit the kind of bonding. This compound, example of compound that exhibit coordinate or dative bonding include number one, ammonium ion, that's NH4 plus. Number two, um oxonium, that's minus O3 minus. Number three, I have H sorry, hexacyanophene 2 and hexacyanophene 3 ion, that's C6Fe6 - 4. I have this. Number four, I have silver, right? Diamine ion, that is AgNH3 plus. So look up, these are the examples of example of coordinate covalent bonding or dative bonding. I have them here. So basically, let me show something, please. In general now, let me show something, please. In general, for ordinary covalent bonding, how do you know them? When you have diatomic, two, diatomic, that's how you identify ordinary covalent bonding. For dative or covalent bonding, how to identify them? When they have what? Ions. Observe, ions, charge, plus, minus, minus, plus. That's how you identify them. And when they're having big compounds, you can see that this one are big compound, that's how you identify a dative or coordinate covalent bonding. All right, let's just take one jam examination and we are off. Before then, we said when it comes to covalent bonding, there are two types. We have the ordinary covalent bonding, we have the coordinate covalent bonding. Aside these two, there are still three more, right? So other types of intermolecular forces include other types of intermolecular forces include number one, have this. Sorry, this 1, 2, AB. It should be C, D, Van der Waals forces. Um, 5, sorry, E, hydrogen bonding. So I have this. These three are referred to as a weak force. So these three here are referred to as a weak forces, right? So that refers to as a weak forces. Let me just try to explain this concept. When you have a camphor, camphor, one white solid like that. That camphor, when you buy camphor, observe that when anywhere you keep it, with respect to time, it becomes smaller, right? Because the forces that is holding the particle are too weak. So I'm saying that when it comes to this, these three forces are weak, are weaker forces. So for that camphor, when you get camphor, when air blows through it, it becomes more smaller with respect to time. After it has been dissolved, it becomes even it will disappear, you do not see it again. Why? Because the forces that is holding the particle are not too strong enough. So when air just pass through it like this, it blows part of the particle away. So the van der Waals force is there is very weak, right? For the particle to be strongly held. So that's like the basic concept behind these ones here. So aside these two, there are still three more exist, but they are weaker forces, please. Let's take just one jam pass questions and we are off. So I'll try to give you this in the board and you tell me the answer, right? So um jam pass question year 2012. Jam pass question year 2012 says that jam pass question year 2012, I have it here, says that the kind of bonding put on place, the kind of bonding, okay, let me write on the board. It says that number one, the kind of bonding in, I have this Cu NH3 4 2 plus is A. I have coordinate. B. I have electrovalent. C. I have metallic. And number D, COVA, covalent. Basically, my answer is A, coordinate. This is a coordinate bonding. Now we said when you're having a bigger compound, observe this is a bigger compound here, bigger compound, right? Something of this nature is that. So it's what under what? Coordinate covalent bond. That's my answer to that question. You can go home and try some past questions yourself. Listen to this, please. Great teacher do not make great students. Great students make themselves great from the instructions of great teachers. So I'm saying now that after this class now, do well to sit inside your house. Take your past questions out and solve questions on this, right? Practice some past questions, practice them so that you can become better in the study of this topic. So see you in our next class. Bye and welcome to Excellent Link Academy.